These are the cow eye note taker. So you need to have your note taker open, which you can find on Canvas, and then just fill in the missing words. I've got them in red, so that shouldn't be too hard. All right, so at the top you'll see we have plenty of diagrams pointing where things are. So if you're a little confused as to what the description, where and how to locate it is saying, then you can look at the diagram. The sclera, it's the outer covering of the eyeball. So if you look at the, it's right here, this outer covering of the eyeball. And it protects the eye, allows the vitreous humor to inflate the eye. The vitreous humor is a liquid, which we'll talk about in a minute. Vitreous humor. The jelly-like liquid inside the sclera, it inflates the eye. If you let that leak out, your eye would be gone. You wouldn't have an eye because your eye is a little bit like a stiff balloon and it's inflated. So people who have injuries of the eye need to keep the liquid inside their eyeball, which is the vitreous humor. The blind spot. Today in class, we're going to look at this here in just a second and how to determine it. It says the place where all the nerves coming from the eye converge to make the optic nerve. So the nerves come together in the back of the eye and they make the nerve. And right where that nerve is, there's no light sensitive cells. So it says since the nerve goes out of the eye, there are no light sensitive cells there. So there is a blind spot. And if I run this down a little bit. Okay, so it says here with your right eye closed. So close your right eye and hold up your left thumb. Right eye closed, left eye right in front of your face so you can see it. Maybe, I don't know, 18 inches out. Then it says put your right thumb next to it. So you should be sitting with your right eye closed and two thumbs out in front of your face. Well, you got your right eye closed. You're going to look at your right thumb and move your left thumb out very slowly. At some point, you won't be able to see, and I don't mean when you get way out to the left, at some point you won't be able to see your thumb. And when your thumb disappears, you've found your left eye's blind spot. But you can only do it one eye at a time. With two eyes, you're never going to see your blind spot because your brain makes up for that. You can see it still in the peripheral of your other eye, so your brain makes up for it. You have to have one eye closed. If you're doing your left eye, you have to have your right eye closed and then your thumb going out to the left to see where, but it shouldn't be so far out that you can't see it because it's beyond your eye's ability to see. If that's the case, you probably went too fast. Okay, iris, a ring of muscle that is colored and is between the cornea and the lens. The cow's eye is brown. Humans come in many colors. There's a typo there, but that's okay. The iris, there's a muscle that contracts that gets smaller. The iris is a muscle, so that muscle contracts or gets smaller and expands or gets bigger to control the amount of light that goes in. The iris closes in bright light and opens in low light. If you have been dilated at the doctor's office, they have put a solution in your eye that makes the muscles relax, making the black spot or hole bigger so the doctor can see inside your eye better. So again, when you step outside in the bright light and you can't see very well and you kind of shut your eyes, that's because there's too much light getting in to your eye. It just takes a few seconds and that muscle closes up, letting less light in your eye. On the opposite of that, if you're outside in the bright and you come into the house, you struggle to see for a minute because your your iris or that muscle needs to open up and let more light in. That again is one of those homeostasis things that your body has to keep things even. Okay, the pupil, the little black circle in the center of the eye. Yours is round, but a cow's is oval. The opening in the center of the iris that is bigger in low light and smaller in bright light. So your pupil is really a hole. It's not really an object. It's a void. Cornea is a tough tissue that covers the iris and the pupil. The cornea bends the light, applying it to the lens so the brain can interpret it as an image. Let me move this over a little bit so it's a little more centered. Okay, so looking at what we have on our diagram, first of all, you have the pupil right here, and the iris is the colored part. Over here, you have the iris, which is the colored part. Then you have the pupil, which is the center opening. The cornea is this cover here, this contact lens shaped cover over that hole. Corneal transplants are possible, and that's something that you can say you'd give if you were an organ donor, is corneas, and it's really common to help blind people when you get them a new cornea. So on this diagram, you can see the cornea, you can see the iris, and the hole is the pupil. Your blind spot would be right here where these nerves go in. Oh, the sclera. I already did the sclera. The sclera is right here on this one and right here on this one. Okay. Aqueous humor. Let me straighten this out a little bit. There we go. Aqueous humor. Notice it's vitreous humor and aqueous humor. Aqueous humor is the clear liquid inside the lens and cornea. It controls the shape of your cornea. So the lens, there's a liquid in there called aqueous humor, and it's inside the lens and the cornea, keeping it a certain shape. The vitreous humor is in the entire eyeball, keeping its shape. The retina, a layer of light-sensitive cells going around the backside of the eye. So in our picture, let's see, is it on this? Yeah, right here. See, there's a little white layer of cells. So light comes through your lens and gets focused, gets bent by the cornea to hit the retina, and those are light sensitive. If there's no light, you can't see because your eyes aren't good. Your eyes work on light. So that's the reason why when the lights go out and there's no windows or it's in the middle of the night, it's pitch black because your eyes need light to see. Okay, and it says detects images focused by the cornea and lens and is attached to the optic nerve to send the message to the brain. So really your eyes don't really see anything. They take in the light and your brain transfers that to a vision or an image. The lens, clear, flexible structure right under the cornea. Makes an image on your retina, can change shape to see close up or distance. Its flexibility decreases with age, making it harder to see both distance and close up. I'm old, so I can see close up just fine. The shape of my lens is perfect to see, to read, or to sew, or to whatever. But when I try to see distance, I have to have glasses. So my glasses have one prescription where I look out, and then at the bottom of my glasses, there's no prescription at all. Okay, moving on. Optic nerve, a string or bundle of nerves leaving the back of the eye to the brain. It carries impulses from the retina to the brain, where your brain interprets the image. Rods. And again, I gotta move this just a shade because it's not all on the screen here. Okay. Rods. Cells that make up the retina. You have approximately 120 million rods. So those are what we call, remember the retina says a layer of light-sensitive cells. Well, some of those cells are called rods. You have 120 million rods. These light-sensitive cells detect black, white, and gray. They also respond to dim light, which is why you see in black and white in low light. So if it's real dark, and you're trying to see, but you got a little bit of light, you're probably seeing in black and white because they're the only things that they're the only cells that would work in that little bit of light. So the rods are the black and white and gray. Cones, cells that make up the retina. You have approximately 6 million cones. There again, the rods are some of the cells that make up the retina. The cones are some of the cells that make up the retina. The cones, these light-sensitive cells detect colors. Your cones detect blue, red, and yellow, and many mixtures of these. You can mix blue, red, and yellow and get any color in the atmosphere. All colors are made of these three, something about them mixed together. Did you ever hear the Barney song? If you hug red and yellow, it makes orange. You don't really hug them, you mix them, but that's what Barney says. So there's an example. Myelin, it's covering the nerve. It's a covering of the nerve fibers, and it's protection for the nerve fibers. So let me back this up, since you've seen the diagrams. Come on. Okay, so here's your diagrams. Here's the lens right here. The lens. The optic nerve is coming out the back. It's coming out the back. Rods and cones would be the cells that make up this layer that runs around the back. Rods and cones making up your retina. Myelin is the covering. There's fatty in here to protect that nerve. So all this would be myelin. Okay, moving on. So myelin, here we go. Myelin is the covering of the nerve fibers, protection of the nerve fibers. If your fibers get damaged, you'd be blind. Tape them, found only in animal eyeballs. Colorful, shiny material behind the retina. Makes animal eyes glow or shine in the dark. I don't know if you can tell this with what you have, but there are some, you see the eyes of the raccoons? And I'm sure you've seen that, you know, your dog or cat or whatever, but not all organisms have that, but raccoons do. Okay, so fill in all these blanks. If you missed any, rewind, and then hit submit in Canvas.